Hi, this is Synthchaser from synthchaser.com. I'm in the process of restoring this ARP Omni 2 and decided to make a video repairing some of the issues. When I restore one of these, I start with a full recap, replacement of the sliders, in this case LED sliders. I repair any obvious issues or bad prior work that was done to the keyboard. I rebush the keyboard, clean the bus bar, adjust the key contacts, etc. And so that's where I'm at now. I've done that stuff. I did take some photos of the synth that I'll show you to give you an idea what state it was in when I got it and what I've done so far. So please forgive this short slideshow. We'll get back to the video very shortly. So I got this ARP Omni 2 in trade as a parts unit, and literally it came to me in parts. All the boards were out of the case. The keyboard was removed. When it was shipped to me, the power supply wasn't screwed down in the case, but the wires were still connected, and it moved around and broke the quick connect tabs connecting the IEC connector to the power supply board. I also noticed the power supply had been worked on. The fuse was removed. There was this huge 5-watt resistor of the wrong resistance value just kind of dangling off the board. And I noticed there was another resistor there that was crudely replaced. I noticed that the leads on one of the ICs on the power supply board were blackened, so I replaced the ICs on the power supply as well as the capacitors and those resistors, repairing the tabs for the quick connects. The sliders were disgusting and stiff, and some of the slider shafts were broken, so I replaced all of them with my LED slider kit that I sell on my website, synthchaser.com. There are places that sell replacement slider kits that look a lot like the originals, but they're not worth it. They're kind of expensive to purchase, these replacement sliders, but they're really just cheap Chinese CTS replica sliders that cost pennies, and the quality is really poor. In fact, last week I installed my set of LED sliders to replace one of these replacement slider kits that the customer had bought and was unhappy with. So anyway, while I had the sliders off my Omni, I recapped those boards and replaced any ICs that were close to the sliders while I had easy access to them. I recapped the entire synthesizer, replacing over 100 tantalum and electrolytic capacitors. This here's the upper voicing board, and there had been some prior work done to the board, but whoever did the work did a sloppy job and lifted solder pads and a trace and soldered a big 1-watt resistor to the board to try to fix the stuff that they destroyed. So I cleaned everything up and corrected it properly. ARP boards are kind of tricky to solder because they're double-sided but not plated through hole, so pads with no traces coming off them are easily destroyed by excessive heat and bad soldering or desoldering technique. It seems difficult for a lot of people to make a good solder joint on both sides of the board. So this is a close-up of my soldering work. You can see the solder fillets on the component side of the board look good. They're nice and shiny. So after recapping all the boards and changing out the sliders, cleaning out any obvious problems I saw, I unwrapped the keyboard, which had been wrapped up separately. And it was gross and filthy, and the keys were not level. Some keys were sticking up higher than others. The bushings were rock hard. So I took the keyboard apart, washed the keys, changed the bushings, and cleaned all the grime out of the bottom of the key bed. So this is a shot of the bottom of the key bed. You see the bus bar runs along the top. This is before I did any work to it. So I cleaned that. You can see it's oxidized there, and I straightened it out. And that's when I noticed that the circuit board for the keyboard that holds the keyboard contacts was cracked. So the way that this works is there's little wires coming off that board, and when you press down on a key, it pushes that in contact with the bus, and it powers that key, and then that signal goes back up through the ribbon cable to the upper and lower voicing boards, so the circuitry knows that the key was pressed. Fortunately, this crack was dead in the center of the connector, so all the key contacts still made contact with their respective pin in that IC socket and made it through the ribbon cable up to the board above. But the power to the upper bus bar comes in on the left side of the board and then runs over to the right and then pops out at the top and runs up to the bus board. So with the board cracked, the power to the upper 29 keys was cut, and this connection had to be restored for the keys to have any chance at working. So that's where I'm at right now. I've done the tedious stuff that should go into all restorations, and now we get to do the fun part and get it working perfectly. I fired it up and looked it over real quick and made a short list of the issues. Some people prefer to replace all the CMOS and the op amps and the synth as part of the restoration as like a preventative measure. And I sell a kit that has all the ICs in the synth. For this synth, to keep the cost lower, I've just replaced the ICs in the power supply and the ones that would be difficult to access after changing to the LED sliders. Even if you don't plan to replace all the ICs, the kit is still good because you'll have all the parts on hand to repair any issues. The recap and other stuff I did has gotten this mostly up and running. So let's take a look at where we stand right now, what we need to do to troubleshoot. I'm going to save the calibration and powering up the LED sliders to the way end. So we have, it mostly works. With some issues. One thing that I noticed is the violin drops out on keys 30 to 39. Another thing that I noticed on all voices, I have a very short release here. Key number 35 has a much longer release than it should. Another thing that I noticed, so I have all voices turned off right now. And I hear the synthesizer voice and the bass. So the switching is not working right because there's bleed through of the synthesizer voices. Another thing that I noticed was the synthesizer bass voices. The string bass voices seem to be working okay. The synthesizer bass voices are not, unless I pin one of the non-bass notes. So when you play synthesizer bass, it is only the bottom 20 keys. So if I pin one of the higher keys, then I can get the synthesizer bass. Otherwise I don't. So these are the issues that we're going to be troubleshooting. So I'm going to open this up and fire up the oscilloscope, and we'll take a look and see what might be going on here. So the first thing I'm going to look into is why this certain range of keys isn't working on 4-foot synth and 4-foot strings. 4-foot strings is violin. So I've engaged the violin, and you can hear it on the upper notes. There is a little bleed through from the synthesizer, is one of the problems that we're going to troubleshoot later. But I get to a certain point and you don't hear the violin anymore, and then it comes back. So based on the number of notes that are out, I have a pretty good idea of what the problem might be. This is the upper voicing board. It has the top octave generator chip. It makes sawtooth waveforms for each of the notes, and then there's gating circuitry, basically, which takes the note that you play, all the different notes that you play, sums them and passes them on to the next board. And on the upper voicing board is responsible for the top 29 keys of the keyboard. And there are these transistor arrays. They have common bases and common collectors. And basically they sum the different notes that you play and pass it on to the next board. So there's about 10 notes per gating IC. This chip is a TDA0470. It's obsolete, so I'm going to want to make sure for sure that this is the problem before I go replacing things. But there's one chip does about 9 or 10 notes for the 4-foot notes, and then the 8-foot notes as well. And I might be pointing them in the wrong direction. When I grab the schematic and poke it with the oscilloscope, we'll see. So I'm going to probe this with the oscilloscope, show you what it looks like when I play some notes, and we'll get to the bottom of this pretty quickly. So take a look at the schematics, and the transistor array number Z39 is responsible for gating keys 30 to 39 of the 4-foot section, so both synth and strings. So what I'm going to do is I'm going to show you what a working gate array looks like in action. So I'm going to look at the high notes and poke around with that, poke at that. So we're going to look at the high key. So this is key 49. So when it's not being played, it's 0 volts. When I play the key, it's about a 1 volt peak to peak sawtooth. So now, like I mentioned, these are transistor arrays, and they're common collector and common base. Base is grounded. The collector is the output. The emitter is what I was just poking when I press the note. So now I'm going to probe the collector, which is pin 14. So this is what it looks like when I'm not playing anything. It's plus 15. So now I'm going to play the note, and you can see there's that sawtooth shows up. I'll play more. Basically, it just sums those, sums the notes that I play. So now let's take a look at the one for keys 30 to 39. So I'm going to play key 39. Let's see, this one. So this is key 39. You hear the synth coming through, not the strings there, but so I'm getting the 1 volt peak to peak on the note, and if I hop over to the collector, I've got 0 volts. So it looks like this chip is dead, but because this is an expensive, obsolete chip, I'm going to make absolutely sure of that before I replace it. I have a replacement, but want to make sure that there's no other problems like on the other side of that. So I'm going to poke around with the multimeter and see if maybe there's a broken solder joint or something else behind that chip, or a bad connection to the board that signal goes to. So the first thing I did was I measured continuity between the transistor array and the connector between the upper voicing board and the lower voicing board. The sum of those gates comes over through this connector, and it comes into the lower voicing board, where it's summed with the gates for the lower 20 keys in this op amp, which is tucked away here, and the output of the transistor array passes through several resistors. So I want to make sure that there's no broken connection there. There's really no active components there, just passives between the transistor array and the input of that op amp. And we know the op amp is working because the other ranges of notes for the 4-foot section work fine. So what I'm going to do is I'm going to measure resistance between this point where the transistor array comes in and where it goes to on the op amp. And since the resistor values are the same for all the transistor arrays, we should have the same value. So this is giving me 14.7K. So now I'm going to hop over to the next range of 4-foot notes. I measured the resistance. It's giving me about 21K. So I'm going to do with the next section from the next transistor array. Again, at 21K. So what I'm going to do now is I'm going to disconnect this connection to the upper voicing board. So I'm going to take that cut the connection to the transistor array, and I'm going to measure this again. If the resistance is still different, then I know that the problem is somewhere with the connection between where the transistor array comes in and where it gets the op amp. If the resistance is fine now, then it's probably a shorted transistor array. So let's check this out. So our problem transistor array, now the resistance is 22K, and the one that was working is 22K. The third one that was working is 22K. So there's no connection problem on the lower voicing board. Let's hop back to the upper voicing board and see if maybe this transistor array is shorted. So this is the one responsible for the 4-foot notes, keys 30 to 39. This is the one that we're having problems with. These two are working. So what I'm going to do is I'm going to measure continuity between the collector, the common collector, and ground, which is pin 7, I believe. So I'm getting 3.7 mega ohms. On the other one, getting 2 mega ohms. On the one that I suspect might be bad, I'm getting 677 ohms. So there is some kind of short to ground here, which is pulling the collector to 0 volts and causing this not to work. So we are going to have to replace this chip, this transistor array, and that should solve the problem of the dead 30 to 39 keys on the 4-foot section. So now we can turn our attention to other problems in the synthesizer. So while we're on the upper voicing board here, we're going to take a look at why this key 35 is taking a long time to release. So I set a very short release, which you can hear, and this key 35 has a long release. So there's a voltage when you fiddle with your release slider, the one on the string control board. It sets a voltage which controls the release time, the time that it takes with these capacitors to recharge after you discharge them when you play the note. So this bus here is that voltage. So with a short release, the shortest release, this voltage is +8. I can make the release longer. So very long release is -15 volts. So we want to make the difference very obvious, so I push the slider back to shortest release, which is 8 volts. So normally these go up through this resistor network, through these diodes, and they meet up with the key contacts when they're making contact with the bus bar that come up through these ribbon cables. Then through these resistor networks here, they discharge these capacitors down to -15 volts, and the time that it takes the note to charge back up, the capacitor to charge back up to the sustain bus or release bus voltage, while it's doing that, it will transmit a signal through the gating array. So let's just follow this from the release bus, and let's take a look at a normal note. So key 49. So I'm going to probe this resistor array here. So it's going through the resistor array, and it's substantially staying at the same voltage. Comes through the diode. So when I press the key, goes down to -15 and quickly charges back up to 8. So now let's take a look at the number 35, and this is the one that had the resistor, the big 1-watt resistor soldered here, and had some lifted pads and stuff. So let's take a look at what's going on. So I am probing the resistor array, the pin of the resistor array, and I'm at 0 volts instead of 8 volts. Now I'm going to go on to the diode. Oh, it helps if I press the right key. So instead of charging back up to 8 volts, it's going to 0 volts, which means that it's going to have a longer release than if it were 8 volts. So I'm going to probe the resistor array of the one next to it. It's 8, touching the pin of the resistor array for this note, and it's 0. So I would have to suspect that there's a cracked solder joint here, and it's this resistor network is out of circuit for this particular key. So let's grab the multimeter and check continuity. So with the keyboard off, I'm going to see if that resistor network is connected for that note. So I'm on the release bus, which goes into pin 1 of the resistor network, and then they come up to these diodes. So I can just touch the diode and see it's a 3.3K. So like for the first note on that, it's reading 3.3K. Next one, 3.3K. Now I go down to the one at the end, and I'm getting 1.45 mega ohms. So there is a disruption in the connection between this diode. Let me actually poke the resistor array directly and see. So here, no continuity. Oh wait, sorry. It's yeah, no continuity. So I'm going to suspect that this is a cracked solder joint here on the resistor network. That would have been easily resolved. I guess that they soldered a 1-watt resistor there to work around that, but I think we can hopefully just correct that solder joint, and that should fix the long release on note 35. So the next area I'm going to troubleshoot is the bleed through of the synthesizer and bass sounds. So right now I have all the different voices, synthesizer and string, turned off. So there should be no sound coming out of the keyboard when I press keys. But I have some bass, I have some synth, and I shouldn't have that. So I suspect there's an analog switch. Basically, when you press the buttons to select the voices, there's some flip-flops that toggle, and the output of those flip-flops is fed into an analog switch, a CD4016. So I suspect that chip is bad. But before we go changing things randomly, we'll verify this. I suspect that the switches are fine and the flip-flops are fine, because when I press the buttons, the LEDs for those voices toggle properly. So I know that the switches and the flip-flops are working. So let's take a look. The 4016 is right up here in the synthesizer control board. We can get to it from underneath. So what I'm going to do is I'm going to make sure that there's power coming to the chip. Obviously there is. It's plus 15. I make sure the ground is okay. So ground is okay. I have all the voices turned off now, so I'm going to look at the control inputs pins for those to make sure that they should be ground. So that's pin 5, 6, 12, and 13. So here's 13 is ground, 12 is ground, 6 is ground, 5 is ground. So now, let's say I play. I'm going to take a look at the 4-foot synth. The input is on pin 2 and the output is on pin 1. So that's the input. And then this is the output. And again, no signal should be passing through. But you can see, maybe if I put it on AC coupling, it'll be a little more obvious. So this is the input signal. And then this is the output. So there is a signal being passed through this analog switch even when it's turned off. We'll take a look at the bass. Let's take a look at the input on the bass is what is it? Pin 9. So that's the input to the 8-foot bass, and the output So there's definitely signal being passed there. It's attenuated, but there's definitely a signal being passed through. So this 4016 switch needs to be replaced to stop that bleed through. So the next thing that we're going to turn our attention to is the synthesizer bass is only working when you pin a higher note. So I've turned on the 8-foot bass and I'm pressing some keys and it's doing nothing. I pin a higher key and then I'm able to play the bass notes. So the synthesizer bass on the ARP Omni 2 is handled here on the bass board, which is not found on the ARP Omni 1. This board is probably the main difference between the ARP Omni 2 and the ARP Omni 1. Other differences are subtle. But there's an envelope generator here and a VCF specifically for the synthesizer bass voice. So the envelope generator for the synthesizer bass is where I would start. There's a test point here, which I will put the probe on, which shows the envelope of the synthesizer bass. So I'm going to press a bass key, and I'm getting nothing. I'm going to pin the higher note. Well, you can see that there is some activity there. When I have a higher note pin. So the envelope generator isn't getting triggered. So the inputs to the envelope generator, there's a one-shot, there's the staccato control, and then there's a bass voice gate. So this gets here via this connector here. So first thing I'm going to take a look at is I'm going to take a look at the one shot. So it's negative 15 volts normally. I'm pressing some bass keys. I'm getting nothing. I'll pin the higher note. Let me do that. So when I have a higher note pin, the one shot is getting triggered. When I don't have a higher note pin, the one shot isn't coming in. Let's take a look at the gate, which is pin 2 on this connector. So I'm pressing a bass note, and the gate isn't really turning on. I mean, it's moving a little bit, but let's pin a higher note, and it should go to 0 volts when it's being gated. I'll release the high key. It drops back down to that negative 10. So so the gating and the one shot isn't coming through. I took a look at the schematics. So now we need to. So we know that the problem isn't down here on the baseboard. It's the gate and one shot that are coming in from the lower voicing board. So now I've turned my attention to the lower voicing board, and I looked at the schematics for that. There's a bass enable, which is on this connector here. So we can make sure so that's plus 15 volts, and there's no effect. Nothing's happening if I'm pinning a higher note or not. So the bass enable is okay. The bass one shot is actually created from the bass gate. So the bass gate is what we're going to want to look into. So bass enable is okay. So it goes through this transistor here into this CMOS transistor array of 4007. So let's take a look at the transistor. So bass enable comes from this connector through this resistor. Let me see if I can do it so you can see. Through this resistor, and here it becomes ground. Let's see. So this is there's this 2N3906. It's a PNP transistor. Let's take a look at the emitter. The emitter is ground. The base is ground. Collector is ground. So it really looks like this transistor is shorted out, because yeah. So this transistor appears to be shorted out. So we're going to change it out, and those are the issues that we've come across so far. So now that we've done the troubleshooting for that, I'm going to change the components that we identified as bad, correct the solder joint that I thought was cracked, and we'll see where we stand after that. So I've made those fixes, and now I've come back to test the keyboard. So I have all the voices turned off, and I'm not getting any bleed through. So synthesizer with it turned off, I don't hear it. The synthesizer bass, we had to pin an upper note to get it to get some sound out of the lower 20. Now it's working without having to pin the note. This range of keys 30 to 39 on the 4-foot strings and synthesizer. It's now working. Key 35 was the one that was releasing too slowly. Let's see which one. Key 35, 49, 48, 47. I'll just cheat and peek in here. This was key 35. So now it releases at the same speed as the other ones. If I give it a slower release time, it will release properly. So so we fixed all those issues that we saw before. And we've discovered a new issue. Some distortion on the string bass. Let's see if that happens on the synthesizer bass. Nope. So we're going to grab the schematics and take a look at this. So the distortion on the bass was my mistake. I had the output on high and the bass volume all the way up, and I'm using a really wimpy amp, so it was actually coming from the amp. So now everything is working well. So what I'm going to do now is I'm going to hook up the power to the LED sliders, and I'm going to put the keys on and do a final calibration. I'll show you the end product. So I hooked the power to the LED sliders and I put the keys on, and I calibrated everything with an oscilloscope. And now everything's working great. So this ARP Omni 2 has been fixed. I'll do a little cleaning up to it, and we'll be installing MIDI in it shortly. So stay tuned for that video. Thanks for watching, and if you have any questions, please post in the comments.